Today we are going to begin section 7.5. We're going to be looking at how to find stationary points algebraically instead of off of a graph. And we're going to use calculus strategies to identify maximums and minimums and create the sign chart. So what we did last week was we were given a graph and then we created a sign chart from that graph. Well, the purpose for that was basically just to get you guys to see how the graph and the sign chart went together. Normally what we do is we create a sign chart and then we draw the graph from the sign chart. So that's what we're going to be working on today, going in the forwards direction instead of in the backwards direction like we did last week. So here's our first problem. We have f of x equals x to the third minus 3x squared minus 9x plus 5. So we don't have a graph at this point. Our goal is to end up with a graph. And so what we're going to do is we're going to find the derivative. We're going to use that derivative to create a sign chart. And then we're going to be able to find all the stationary points and classify whether they are maximums, minimums, or inflection points. Okay, so let's get started. Let's begin by finding the derivative. So the derivative, I'm going to move that 3 down and subtract 1 from the exponent. And I'm going to move that 2 down and subtract 1. All right, and I'm going to set that equal to 0 because in order to create a sign diagram, I need to know the critical numbers. So I'll take my derivative and set it equal to 0. Okay, so again, at this point, we have two options. Those of you who are going on to prob stats, you want to just put that in your calculator and find the zeros. Those of you guys who are going into pre-cal, you need to practice with your factoring. So I'm going to take that 3x squared minus 6x minus 9, divide by 3 all the way across because that's my GCF. And then I'm going to factor that. Set both my factors individually equal to 0. That's the zero product property. And I get x equals 3 and x equals negative 1. Okay, so I'm going to move those up here so I can create some more space. 3 and negative 1 are the values that I need to create my sign chart. So let me get rid of my factoring. Okay, so on my sign chart right now, I have negative 1 and I have 3. I know both of those exist. Those are not asymptotes, so I can put solid lines on both of those. And now what I need to determine is whether the derivative is positive or negative in each of these three intervals. So the way I'm going to do that is I'm going to pick a number in that interval and I'm going to test it. Okay, so let's think a number less than negative 1. Well, that would be like negative 2. So I can put negative 2 in place of x. All right, and then I can type this in my calculator or I can figure it out by hand. Negative 2 squared is 4. 4 times 3 is 12. Plus 12 minus 9. 24 minus 9. It honestly doesn't matter what 24 minus 9 is. All that matters is that it's positive. So it's greater than 0 in this interval. That's really all I need to know. I need to know, is my answer to that going to be positive or is my answer to that going to be negative? Okay, so now let's pick a number in between negative 1 and 0. That's my next interval. Well, the easiest number to pick in there is 0. So I'm going to put 0 in place of all my x's in the derivative. And I end up with 0 minus 9. Again, it doesn't matter whether that's positive or negative. What matters, it doesn't matter what the number is. What matters is whether it's positive or negative. At this point, I can see that it's going to be negative. So I'm going to put that in there. All right, and you might be tempted in this last one just to go ahead and say, well, because it was positive and then negative, I believe this next one is going to be positive again. And it might be, but we need to check it because it could be an inflection point as well, and it could just be negative, negative. So let's take a number larger than 3. That's something that would be in this third interval, like 4. And I'm going to substitute that in place of all my x's. So 4 squared is 16. 16 times 3 is 48. Negative 6 times 4, negative 24, minus 9. Well, I know that's going to work out to be greater than 0. 24 minus 9 is going to be bigger than 0. So again, that's going to work out to be positive. So in this case, it did work out to be positive, negative, positive. All right, so let's see what that means. If it is positive and then positive, when it's positive, I know my graph is increasing. When it's negative, I know my graph is decreasing. And then when it's positive, I'm back to increasing again. Okay, so we have created our sign chart. We have the behavior of f of x in each interval. And now we need to classify the stationary points. Well, -1. If it's increasing and then decreasing, -1 must be a maximum. And right here, if it's decreasing and then increasing, 3 must be a minimum. So now I have all of the information that I need. And I would come over here and I would put this on a graph. So what you would have to do, you can see that I've got -1 as a maximum up here. I've got +3 as a minimum right here. And these numbers, the y values, came from substituting -1 and substituting 3 into the original function. Remember, if we substitute them into the derivative, we're going to end up with 0. That's what they came from. So we substitute them into the original function. Now, most often your graph directions are going to say label all relevant points. Well, that's going to be your x-intercepts, which you can see here, here, and here. Also your y-intercepts, and then your maximum and your minimum. Those are going to be all the relevant points. Now, if this were a calculus class, there are some other relevant points that you have to find, and also you would find these points using algebraic methods, but because you are allowed your calculator on the IB exam, then this would be a calculator type question. And once you have proven that you know how to find -1 and 3 using calculus, you can then pick up your calculator and find the rest of those points. Okay, now here's something that you need to be aware of. I have graphed that same f of x from before, and I have also graphed the derivative, the 3x squared minus 6x minus 9. And I want you to just look at some things about those two graphs. Do you notice that when my derivative is equal to 0, that's where the graph of the original has either a maximum value or minimum value. So those things kind of match up. The maximums and minimums match up with where it crosses the axis. One that you'll find if you choose to take calculus is this one, where my derivative has a minimum point is where my graph has an inflection point. Can you see that the curvature changes? On the left-hand side of that, it's curved in a downward manner, and on the right-hand side of that, it's curved in an upward manner. So the minimum value, or it could be the maximum value if my graph were different, but wherever my derivative has a critical number is where my original has an inflection point. And you'll learn more about that if you choose to take calculus. All right, something else I want you to notice is that when my derivative is positive, that means my derivative is above the x-axis. That's this part here. You can see, oops, I forgot to highlight my thing. Sorry, that's this part here. Okay, the derivative is positive. It's above the x-axis. The derivative is also positive here. It's above the x-axis. And you can see that is where your original function is moving up. That's where your original function is increasing. Your original function right here is increasing. Similarly, where your derivative is negative, that's this part below the x-axis. And where the derivative is negative is where the original function is going down. It is decreasing. So there are times, especially in calculus, where you'll be given the graph of a derivative and you have to draw the graph of the original or sketch it really, or you're given the graph of the original and you can sketch the graph of the derivative. You can go back and forth using those ideas about what you know with maximums, minimums, increasing, and decreasing. Okay, so here's a good one for us to look at, taking your Algebra 2 knowledge into consideration. So this says, I have a quadratic in standard form, ax squared plus bx plus c. I know that a is not 0. If a were 0, it would be linear, right? Because the x squared term wouldn't actually be there. And this has a stationary point. The question is where? Okay, so to find stationary points, we'll take the derivative. So I'm going to move that 2 into the front, subtract 1 from the exponent. 1 times b is b, and then the x to the 0, that goes away, and the derivative of c is 0 because it's a constant. So there's my derivative, 2ax plus b. I'm going to set that equal to 0 to find the stationary points or the critical numbers. Subtracting b from both sides. Trying to get x by itself, I'll divide by 2a. All right, and you might recognize that from Algebra 2. That is the formula for the axis of symmetry of a quadratic. Axis of symmetry always goes through the vertex. The vertex is either the maximum or the minimum, so it makes sense that the maximum or the minimum would occur at a stationary point. But that formula that you had to memorize in Algebra 2, which didn't seem to have any context to it, it's just a formula, here it works. This is the reason why it works. This is why you couldn't get the context of the formula, because it comes from calculus, which you hadn't seen yet. So anyway, there's the formula that you learned in Algebra 2 for finding the axis of symmetry of a quadratic. Okay, so let's look at this one. F of x equals x plus 1 over x squared. All right, so we're going to find the derivative, create the sign diagram, and then look at the behavior in each interval. Okay, so let's see what we can do with that. So let's first find the derivative. Well, I noticed that that second term in my original is a fraction, and it would be easier if it didn't look like a fraction. So the first thing I'm going to do is rewrite this, make it x to the negative 2 power. And now I'm going to take the derivative. The derivative of x is 1. The derivative of x to the negative 2, negative 2x to the negative 3. And then I'm going to turn that back into a fraction because that's going to be easier when I go to set this equal to 0. If I have a positive exponent, that's just going to be a lot easier to deal with. So I'm going to add the 2 over x to the third to both sides. Multiply both sides by x to the third. And then take the cube root of both sides. So x equals the cube root of 2. Cube root of 2 turns out to be my stationary point that I have there. Okay, but remember there's also stationary points where your derivative is undefined. So look at this part. Do you see that if I had x in the denominator, that would, if I had 0 in the denominator, that would be undefined? So not only do I have the square or cube root of 2 as a stationary point, I also have x equals 0 as a stationary point because 0 would make it undefined. All right, so now when I get ready to draw my sign diagram, I need to have a dotted line on 0 because 0 is undefined, and I need to have a solid line on the cube root of 2. So there's the beginnings of my sign chart, and just like last time, my goal is to figure out what the value of the derivative is, at least whether it's positive or negative, in each of these 3 intervals. Okay, so let's pick a number less than 0. Let's try negative 1. So I'll take negative 1 and I'll substitute it in there. 1 minus 2 over negative 1 to the third. Okay, so when I do that, negative 1 to the third, that's going to be a negative number. And negative, negative, that's going to be positive. So I know that this is going to be positive, which means it's going to be increasing. All right, now let's pick a value in between 0 and cube root of 2. Well, I don't know cube root of 2 right off the top of my head, so I'm going to type that into my calculator. It's about 1.3. So I can use 1. 1 is a number in between 0 and 1.3. 2 over 1 is 2. 1 minus 2 is going to be less than 0, so that's going to be decreasing. And then something bigger than 1.2, 1.3, let's try 2. All right, 2 to the third is 8. 2 over 8 is 1/4. So this is going to end up being something that's positive. And so there is my completed sign chart. This one that's decreasing and then increasing is a minimum. This one is an asymptote, so I do